we are going to continue discussing about Young's double slit experiment, and we said that it is a proof that light behaves like a wave. And how does this happen? Suppose you have a source. We said in order to produce a sustained or fixed interference pattern on the screen, and the light sources and the light from the sources, those two sources should be sort of coherent sources. That means here, in order to form a coherent source, there are many methods. Let's discuss about the first method, that is wavefront splitting. So light from the source is, light is kept in front of a lens of focal length f, then exactly at a distance f, if you place a source, light from this source, after passing through the lens, it will come out as a plane wavefront. We say parallel rays in ray optics. Here light is a wave, so that's why this wavefront is called plane wavefront. Plane wavefront. So if you interfere this a cardboard with having two holes, so after passing through this light, every point in this plane wavefront act as a secondary source according to Huygens principle, and this light wave will come here, and through this will. So light from these two openings act as secondary sources. These two sources are obtained from the same source. So these two sources, source 1 and source 2, are called pair of coherent sources. So when these lights interfere, they interfere constructively and destructively on the screen. There is a bright spot, and then there is a dark spot, and then there is a bright spot, and then there is a dark spot on that. So like that it keeps on forming. So we'll be interested in where all on the screen it produces bright spot, where all on the screen it produces dark spot. So we usually find the intensity and amplitude of the interfering waves using the formula. Separately we dealt it. So suppose the resultant amplitude, suppose light of amplitude A1, light of amplitude A2. So amplitude square, resultant amplitude square is equal to A1 square plus A2 square plus 2 A1 A2 cos phi. This is how we find the resultant amplitude. But intensity is actually proportional to amplitude. Intensity is proportional to square of the amplitude, which means that intensity is equal to some constant into a square. So multiply the whole thing with the constant k. So k into a resultant square is equal to ka1 square plus ka2 square plus 2 k a1 a2 cos phi. So when I take square root here, what I will be having is root over I is equal to root k into a. So this thing, k into a resultant square is equal to I resultant square. This is not I resultant square, I resultant equal to I1 plus I2. This one I am writing root k into a1 and one more root k here, root k into a2. So this becomes like root k a1 is actually I1. So 2 into root I1 root I2 cos phi. So which means the intensity of the resultant wave formed on the screen, I resultant, is equal to I1 plus I2 plus 2 root over I1 I2 cos phi. Suppose when we obtain sources like this one is called wavefront splitting. So from the plane wavefront you are actually producing two light sources. So because of that, what happens, the intensity of the first wave is also equal to intensity of the second wave. So we can say I1 is equal to I2, which let us call I. In such case, what happens, I resultant equal to I1 is also I2 is also I, plus 2 root of I into I cos phi. So here I resultant is equal to 2I I into I square plus 2i. If the phase difference must be 0 in order to produce a bright interference, so if phi you set it as 0 degree, then it is cos 0 degree. So cos 0 is 1, so I resultant is equal to 4i. So this is a striking thing. Suppose you have two light sources, source 1 and source 2. If the interfering intensities are high, the bright spot here will have 4 times the intensity. All the bright spots will have 4 times the intensity. All the dark spots have 0 intensity. This is, see, suppose if interference does not happen, what will happen? Actually, light from the source having intensity I, light from this source is also having the same intensity I. When these two intensity falling on each other, intensity will become only 2i. But now the intensity is 4i. That's a proof that they interfered, and as a result of interference, intensity becomes 4 times. So when the two interfering intensities are same I, then the resultant intensity will be 4i. Okay, and here energy conservation is not violated. Law of energy conservation is not violated. See, here the energy is redistributed. So 4i, suppose if both the waves don't interfere, what happens? Uniformly intensity will become 2i. So but here it is 4i and then again 0, 4i. So if you take the average, it becomes 2i. So over the entire space on the screen, the energy is redistributed, but energy conservation is not violated. So one more general and useful formula: if this intensity is like this, I1 I2 plus 2 root over I1 I2 cos phi, this one you try to remember. Or another way, if phi is 0, this is the thing. If phi is not 0 and both the interfering intensities are I, this IR is equal to I plus 2 root over I square will be 2I cos phi. So 2i plus 2i cos phi, I will take 2i out, 1 plus cos phi. 1 plus cos phi means resultant intensity 2i into 2 cos square phi by 2. So I resultant in this case equal to 4i cos square phi by 2. This is the resultant intensity on the screen, because in Young's double slit experiment both the interfering intensities are same. So this is it. If phi is equal to, let us say, pi radians. Pi radians means if one wave is like this, the other wave is like this, so they are out of phase. In such case, crest meets trough, so the resultant intensity will be 0. If you substitute it here, you will get I resultant is equal to 4 times I cos square pi by 2. So pi by 2 is 90 degree, cos 90 is 0, so the whole thing becomes 0. We'll continue the discussion in the next video.